All right, graphing a piecewise defined function. So recall, a piecewise defined function is a function that has different rules for different parts of its domain. So in this example here, we're going to sketch the graph of y equals 4x plus 11 for the values of x between -10 and -2. So I'm going to figure out where to start. Now, normally this is a linear equation, right? If we're back in math 1, we're going to start at our y-intercept of 0, 11, and then go up 4, right 1, up 4, right 1. But none of that is in that given domain. So what I'm going to do is I'm going to use a table of values so that I know the value of my function over that given domain. So when x is -10. So when x is -10, the value of my function is -29. So I'm going to plot that point, -10, -29. Now this is way off my graph. Normally from here now, I would continue to use slope to get the rest of my line over that domain, you know, go up 4, right 1, up 4, right 1. But because I'm off graph, I don't really know what up 4 looks like. So instead, I'm going to use a table of values to get another point on my graph. Since this is a linear equation, I know that it has a constant rate of change. So another point I can connect but with a straight line. I don't have to worry about the curvature between these 2 points because it's a line. Nice. So this point, -5, -9, is on my graph. So now I'm going to keep using slope for the rest of my domain. So up 4, right 1, up 4, right 1, up 4, right 1. And I'm going to put an open circle at this coordinate -2, 3, because my graph has the shape of 4x plus 11 when x is less than -2, so not equal to -2. I'm going to cheat a little bit and use my technology here to graph that line, because I know there's no way I'm going to get a nice straight line if I try to do that by hand on this Chromebook. So there we go. There is our function over the domain -10, -2. So now we're going to sketch the graph of y equals x squared minus 1 for the values of x between -2 and 2. So this graph is a quadratic that's been shifted down 1. So I don't need a table of values for that. We just had a lesson on parent functions. X squared is a parent function. I know that function inside and out. So what I'm going to do is I'm going to use my transformations to graph this. So I know my vertex has been shifted down 1. And I'm going to graph my parent function now. Just shifted down 1. And notice I filled in the coordinates -2, 3, and 2, 3, because this is defined at -2 and 2. And last, we have a linear equation. So we're going to sketch the graph y equals x plus 1 for the values of x between 2 and 10. So really quickly, I'm going to do just a quick table to figure out what my function value is at 2. So 2 meaning, oh, wrong color, hang on. Yellow, I can't graph yellow. Maybe I could do this mustard color, see if that shows up. Yeah. 2 plus 1, which gives me 3. So 2, 3. So same location as my other one, but I have an open circle here because x is greater than 2, takes the shape x plus 1. And then my slope is 1, so I'm just going to keep using slope until I get to the end of my domain, which was 10. And filled in circle at that point 10, 11, because x is less than or equal to 10. And that's how you graph a piecewise function. So table of values, our knowledge of transformation of functions, but the main thing to remember is that the piecewise graph takes the shape of the given function over the given domain. So the shape of 4x plus 11 over the given domain, negative 10 to negative 2. The shape of x squared minus 1 over the given domain, negative 2 to 2. The shape of x plus 1 over the given domain of 2 to 10. And all that together makes up a singular function. So now let's answer our questions. What is the domain and range? So domain, all possible values of x. So if we're looking here, our domain ranges from negative 10 to positive 10, defined on both ends, so brackets. And our range, our values of y, our lowest value of y is negative 29, and it was, again, defined at that value, up until our largest value is 11. And again, it is defined at 11 as well. So there's our domain and there's our range. And our intervals of increasing and decreasing. So our function is increasing from negative 10 until negative 2. And then it decreases to 0, but increases again from 0 to 10. So my function is going up, it's increasing. Let me get my highlighter. Increasing, 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 decreases, then increases again. So there's our intervals of increasing. Now if we're looking at decreasing, our function's only decreasing between negative 2 and 0. And remember, intervals of increasing, decreasing never have inclusive endpoints. We'll always have parentheses for intervals of increasing and decreasing.